Hey everyone, in this video I'll be talking about DiceDB and how you can set it up on your local machine. So in case you're unaware, DiceDB is a Redis compliant, reactive, scalable, unified cache which is optimized for modern hardware. DiceDB is Redis compliant, so which means you can use a familiar interface, the same that you use to interact with Redis, to interact with DiceDB. So you don't have to learn anything new. And even all your Redis tools will also work with DiceDB. It's reactive, which means that it has support for query subscriptions. So what this means is that you can subscribe to data updates and those updates are pushed to you instead of you having to poll for them. It's also scalable, which means that it scales up with your hardware. So unlike Redis, which is single-threaded, DiceDB is multi-threaded and it takes advantage of every single CPU core that you throw at it. It's also aiming to be highly available and multi-tenant, which are features that we are currently working on. However, in this video, I won't be going too deep into what DiceDB does today. Instead, I'll be focusing on how you can set up DiceDB and how you can start using it. And in fact, I'll also go into how you can make your first contributions to the project. So let's go ahead into the DiceDB repository. And it's available on github.com/dicedb/dice. And the fastest way that you can actually start using it is using Docker. So if you just look up Docker on the page, you can find a Docker command that you can run to launch the DiceDB server. And all you really need in this case is Docker engine installed on your machine. So I'm on Linux, so that's always available. So I can just copy this command and I'll open up my terminal and paste it there. So it's a regular Docker run command. We expose port 7379, which is what DiceDB operates on. And we see that there is an additional flag here, which is called enable watch. It is used to enable the reactivity features, which we won't really be going in too deep in this video. So I can actually remove that flag. So this should be enough to actually launch the DiceDB server. So if you run this, you'll see that we have some basic information being displayed. We know that how many cores are there on the machine and how many shards we are running. So shards is the primitive that we use internally for DiceDB to map to each of your CPU cores that is available to drive out performance. And we have a couple of other flags that we can see detailing some of the features that we have. So we've disabled reactivity, we've disabled profiling, and we have enabled persistence by default. So once you have DiceDB running, you can actually use the DiceDB CLI to interact with it. So in case you want to get to the DiceDB CLI, you can go to the DiceDB CLI repository, which is linked on the main DiceDB repository, and just copy this one command into your terminal to install it, right? So let's open up another terminal and let's launch DiceDB CLI. So as I said, it follows the REST protocol, and you can use any familiar Redis command to interact with it. So if I do something like set kv, we have set a key k to the value v, and we can read that value. So if you do get k, you'll get that value back. You can also do deletions, pretty much similar to Redis. And if you try to fetch the key again, you will get a nil, right? So that's the basic way on how you can actually interact with the DiceDB server. And that should be enough for most people if you're just looking to use it as a plug-and-play in-memory database. However, if you're looking to contribute to the project, you would probably want to set up the code base on your local machine. So let's go ahead and see how we can do that. You can just clone the repository using git clone. I already have it available locally, so I'll just navigate to that directory. And I'll just ensure that I'm on the latest commit. Once that is done, I can open it up in my favorite IDE. I will be using Goland. And on the left-hand side, you can usually see all the files that are available and the entire code base. So there are a couple of directories here. And before diving into those, we'll just see how we can actually run this project. So we'll do something very similar to the Docker run command, just so we can make sure that we have the project in a running state. So I'll open up the terminal in this directory, and I can just run go run main.go, and that should probably be enough. And you'll see a very similar output as what you saw in the Docker run command. It might be a little different since the Docker image releases happen at a separate cadence from the commits that go into the repository. So you might see a few changes here and there, and some features being different in the head commit of the repository and the Docker image that is available on Docker Hub. So we have DiceDB running again, but this time through building it locally, and we can use the DiceDB CLI again to talk to it, and we can run a similar command and ensure that it's working fine. Cool. We can just close this for now. Now, how do you actually get started with contributing to the project? So the easiest way for anyone that I recommend getting started with open source is not to dive directly into the code base, but rather into the tests. So I have this directory here, which is called integration tests, which are obviously integration tests. So you can go into some of the commands and into the RESP server. RESP is basically the multi-threaded server that we have. We call it the RESP server. And you can see that there are integration tests for almost all commands that DiceDB supports. The simplest of these commands is the set command. So you can see that there are a few tests that test this functionality, and you can actually run one of those tests and see that they are working. Of course they're working, right? They are already merged. So how do you start with tinkering with the project? So the easiest way to do so is trying to break some tests. And how do you do that? So you know that you're testing the set command here. Let's try to locate where the set command is actually defined, right? So what you can usually do is just look up the keyword that you think probably matches what you're trying to find, right? So if you try to look up set, you will see all the different kinds of functions or classes that are similar to what you're looking for, right? I know that I probably want to search for something like eval set because that's the naming convention that we use in the project. So if I search for eval set, I will see that this function is available here inside the store eval file, right? And I can probably go through this and I can try breaking certain things, right? So let's see. What if I remove something that is probably expected somewhere, right? So let's remove this line here that actually persists something into the in-memory store when you use the set command. So you can see that near the end of this function, after we have parsed all the arguments and we've passed all the options that the user might have supplied, what we do at the end is putting it into the in-memory hash map. So if I remove this and I go back to my test and I try running that test, okay, so we have like something that is not working. So, okay, we can actually just remove this as well. Doesn't matter, right? And we'll remove this and we'll remove this maybe not. So just to make sure that we don't have like warnings of unused variables, we can just print something here. So now going back to the set test, we can run this again, and you'll probably see that once it runs, we'll probably have some errors, right? So since we are no longer persisting the data into the in-memory hash map, you are expecting a certain value to be present, but in fact, you get back a nil response. And this is how you probably see like how things are wired up. This allows you to see how different components interact with each other and how changing one thing can lead to a change in the output, right? So I'll undo these changes for now and go back to the original state that the repository was in and try to see what I can improve here. So what you can see here, I actually found this issue today itself while just browsing the repository. So what you notice here is that what we do in this set command implementation is we try to gauge what is the type of the value that someone is storing for a particular key. So if you have set k, if you have a command set k space v being a string, you store it as a string. However, if the user sends something like set k 123, so if someone does something like set k 123, if this value is an integer, we would parse it as an integer and we'll store it in an integer form instead of storing it as a string, right? We found this to be more efficient. We found this to be a much better implementation for what we are trying to do here, right? So what I've noticed here is that the way we do this is we get the type of the object. If it's an integer type, we parse it as an integer. So this would return us an integer and we store it here, right? In case it's not an integer and it's a string, we store the value directly as it came to us, and we put the stored value, which could either be an integer or a string, directly into the hash map, right? So what I noticed was that we get this object type here, and we get that from this method that we have called get raw string or integer, right? So what I thought was, what I actually saw was that we are ignoring one of the return values and we're only using the other one. So the one value that we ignore is the type casted value. So in case we if we have an integer value, we already cast it to integer in this method. In case we have a string value, we cast it to string. And we don't need to actually cast it to string, it like already is string. So we return the value as it is, but if it's an integer, we return the casted integer value, right? So we actually ignore this result, which doesn't really make sense because at the end of the switch case, we are actually doing the same thing here again. So it's sort of like an efficiency degradation here, right? We are doing a parse int twice when you don't really need to do that. So what I thought we could do was replace this entire switch case by simply getting the stored value directly from that method up there. So if I just write stored value here and I remove the logic to get the stored value and simply replace it with an if condition that just checks the error case. So if object type is not equal to integer or string, then I want to return an error. So thanks to Copilot, that's pretty easy, and I can simply delete the piece of code here. Right. So once that is done, I can probably test my changes again, right? So let's go to the set test method and we can try running the set test cases, and hopefully they work. They do. And we can run all the tests like this. You can actually use the make command to run the entire test suite, which is what you should actually do when you are actually working on these changes. So you can actually run like make test and it would run all the tests, but I'm not doing that for now because they take like a couple of minutes to actually finish. And if you really want to, if you think that your change is actually ready to go out and be reviewed and possibly be pulled into the repository, what you can do is create a pull request for the same. So you usually would not really develop directly on master. So I'll just stash my changes for now, which sort of like puts away these changes that I've just made into like a temporary stack. And I can check out into another branch. So I can call that set optimizations, and I can check out to that. And yeah, we can do git stash pop to get those changes back. So you can see that those changes are again applied here, and I can add them into the staging and then I can commit them. So it's a very vague commit message, which is probably not really good, but it's all right for this tutorial, and I can commit it. So once that is done, I can actually do a git push, right? So once I do the git push, it will actually allow me to push this branch up, and it will allow me to create a pull request by visiting this one URL, and I can create a pull request like so. Usually you shouldn't have like an empty description. You should have something that describes the changes. Uh, and yeah, it'll run, we'll usually run the entire test suite and the linter on top of your changes. And if there are no issues and the code is meaningful, we'll merge it in, right? So I'm not sure if this change will pass all the tests, because oftentimes like simple changes which look simple, they end up breaking stuff. So I'm not sure if we'll push this change in, but yeah, this is how you can actually make certain changes. And in fact, if you're a first-time contributor to the project, these tests won't really run, because GitHub doesn't really run the CI for first-time contributors, just to prevent spam and someone sort of like maliciously running your CI again and again with new accounts. So the first time that you make a change, one of the maintainers of the project will have to approve that change to run on the CI. And once that's done, we can probably review the CL, review your PR, and if everything looks good, we'll merge it. And that's basically how you get started with setting up DiceDB on a local machine. You could use Docker for that, or you could set it up from source code. And this is how you actually make your first few changes in. So yeah, that's it for this video. Looking forward to seeing some new contributors in the project. It's a pretty active project. So if you look at it, we have quite a few contributors here. We have somewhere around 170 contributors, 180 almost now. So it's a pretty active project. The community is really helpful. You can join our Discord server as well, if in case you need help or if you're stuck somewhere. And yeah, that's mostly it. And I'll see you guys in the next video. Bye-bye.